Hello and welcome to today's webinar entitled Skip Staging, Test Docker, Helm, and Kubernetes Apps Like a Pro with Dan Garfield, Chief Evangelist Codefresh. Dan has a great presentation and a wonderful demo to show how Codefresh can help you automate app testing and deployment to Kubernetes in just minutes. Hi, my name is Ken Drachnik and I'll be moderating today's session. The Q&A panel in your GoToMeeting desktop is the best place to submit questions you have for Dan as he goes through the presentation and a demo towards the end of the presentation today. We'll get to as many questions as we can, and we'll try to save the last 10, 15 minutes or so for Q&A, but we'll get to some Q&A during the program as well. We are recording this session, so look for a link to the recording in your inbox in the next couple of days. And with that, I'll hand it over to Dan to do an introduction and tell you what we're going to do today.
Thanks. So my name is Dan Garfield, and today's topic is skip staging, test Docker, Helm, and Kubernetes apps like a pro. And that's kind of a fancy way of saying that now that we live in the Kubernetes world, we don't have to rely on these sort of static test environments. We can do it in a much more dynamic way. And we're going to leverage all this technology to do it, but it's actually a lot easier than you might think. Like I said, my name is Dan Garfield. I work for a company called Codefresh. We built, actually this slide is a little old, over 3.5 million images, but we're probably over 4.5 now. We work with companies like Giphy, HP Enterprise, ARM, Figaro, some companies that you'll know. And basically we've been around we launched about 18 months ago, and I'll tell you a little bit more about us, but basically what we're going to cover today is we're going to look at sort of traditional staging methods and how Kubernetes changes that game. And then we'll talk about some of the elements that go into scaling those test methods. And we'll give you a demo of how that works. And it'll be something that's repeatable that you can take home and do yourself if you like. So just to introduce Codefresh a little bit, Codefresh is basically a CI/CD platform built for Kubernetes. And where we sort of differentiate ourselves is there are a lot of old school tools out there to do continuous integration. There are a few tools to do continuous delivery. We do both of those things. And we also have a big focus on what I would say are sort of the cloud native technologies, Kubernetes, Helm, Docker, Istio, those kinds of things. And so that's basically where we fit in. And we're part of the Saucelabs TAP program, the Technology Partner Program, which is basically Saucelabs launched this a few months ago, and it's a directory of, I guess you would say, technology partners who provide these services. So they have stuff for orchestration, for test creation, visual management. Codefresh is in the CI/CD space where, basically every time you commit your code, we can throw Saucelabs against it in a really scalable, repeatable way. So that's the program that we're part of. And I think that, Ken, you'd say that basically if you're in the technology, if you're in the TAP program, that your stuff is guaranteed to work well together. Is that kind of how you describe it?
Yeah, and I think we also work with a number of system integrators and other technology partners who can help people, develop tests, pick platforms. They can help people integrate tests, and they can provide, integration with all these other services as well.
Yeah, absolutely. Good. Okay. Yeah, and one of the other, I think, test creation tools, you guys have Testum in there, which is also another one of our partners. So there's sort of a seamless integration between even a lot of technology partners between each other, which is cool.
Yeah, and we have a lot of other companies we work with that are not necessarily true, partners, but then they are in the test management, test creation space, and they run their tests on Saucelabs, right? So a lot of folks who are in this space use Saucelabs as a default testing platform.
Right. Okay. So, most of you that are here probably understand why we do testing, but just as a reminder, this is a great GIF showing why we have this really functional trash can, we have this really functional hand dryer, but when you stick them together, it creates mayhem. And this is the whole point of integration testing, right? Is that you get all of your stuff actually running, and once it's all actually running, let's see what happens. And that's when we find out really if our application actually works. And so this is where I think Saucelabs has a really important role to play, because when you're doing UI testing through Saucelabs, if you stand up your whole application, then you're actually getting a much deeper level of testing, because you're able to show that the behaviors are what you expect. And so Codefresh is basically integrating with that capability, where we're sort of running the pipeline and building the images and deploying and all those things. But this is really why we test it, right? So this is why we have this UI testing. So I want to talk for just a moment about this idea of what we call shift left. And shift left basically says that the earlier that testing happens, the cheaper it is to make fixes. And so if you think about this is sort of a traditional, most of you will recognize this Git flow here, where typically there's this idea that we have a staging which happens when it goes into the staging branch. And if you are a small organization, you might have one staging server, and there's a pull request that goes, and once it's accepted and there's code review, it goes into the staging server. There it's validated, integration testing actually happens, and then if that's validated, then it moves up into production, into the production branch, where it's then actually deployed. But the problem with this is that it introduces all of these costs that we don't have to have. And when it comes to Kubernetes, you basically unlock a couple of cheat codes that make it so that we can actually test our application much earlier and in a much more prolific way. So rather than having like one staging server or even n number of staging servers, we can actually just launch short-lived environments for every commit, and then pass all of that feedback over to the application engineer to actually to fix it before they even do the pull request. And that means that when you do the pull request, instead of doing code review on something that we may not even know if it works on the integration level, they can actually just do a code review on something that's already been fully validated. And when we look at that, the effect that has, basically it's a huge cost reduction, because the later in the development cycle that you discover a bug, the more expensive it is to fix. Like if you've already done code review and pushed it into a staging server, and then there's a bug that you discover when you do integration testing, well, that means you basically wasted everybody's time before that, and you're probably involving more people. Now, if you can capture those bugs right when you make the commit, then the cost to fix that's going to be very inexpensive. And just from a mindset standpoint, if your engineer is working on something, they commit it, they push it, it builds, it runs the integration test, and they get the feedback, their headspace is already still sort of plugged into the changes they were just making. So they're going to be a lot faster to change things and make fixes. Now, there was actually a survey run about how people are doing in this process. I'll give you the source here in just a sec. And basically what it says is that the people who have really shifted left are those people who can deploy any minute of any day. And that's basically 2%. It's a very few, very small portion of the engineering teams out there, with some better, a couple of people who we could ship daily probably if we wanted to, but not any minute of any day. And most people are stuck in this, well, we're starting to test kind of earlier, but it's very extended. We can't release that fast. And what happens when you do that is you end up just keeping these sort of features that you're working on sitting around when they could be realizing business value in production, right? So you want to be able to validate it automatically so that you can release more often. And really, you want releases to act like an assembly line, right? Where you don't really have to, where basically it's automated. You don't have to have a lot of hands-on for the whole process. And in order to get there, you're going to need more confidence, right, in your testing, in your test processes. So what has stopped people, what stopped people from getting everybody into this last column of having a deploy at any minute? Sometimes it's, the tests themselves, having confidence in your tests. But in fact, there was a survey run on this by WQR where they found that the lack of appropriate environments was the chief obstacle to shifting left, which meant that they had the tests in place, but they couldn't do them at scale. They couldn't do them, they basically had a set number of staging servers, and they had to manage those. But we can sort of skip that whole staging idea with what we would call these sort of short-lived Kubernetes environments. So let me show you what that looks like. This is what we would sort of call a Kubernetes pipeline. This one's leveraging Helm. And this gives you an idea of kind of how Codefresh approaches the software development lifecycle. Basically, you make your commit, maybe that's on GitHub or GitLab, Bitbucket, whatever, we don't really care. But you make your commit and you push it. And once you push your commit, it fires off a webhook that's going to do some sort of Docker, multi-stage build. And then it's going to build and install a Helm chart. Now, if you're not familiar with Helm, it's a package manager for Kubernetes. Basically, it generates all of your Kubernetes YAMLs so you can apply those in a structured way. And it basically makes it so that your application is defined from top to bottom with all of its associated services, basically a Kubernetes application. I realize you can't see the air quotes I'm making. But once we deploy this Helm chart into a short-lived environment, then we can run integration tests, performance tests, security tests, all of these as if it were a staging server. And in effect, it is, except the difference is we can have any number of these happening concurrently. There's nothing to stop us from having 1,000 concurrent quote-unquote staging servers at once. We're not because they're not a staging server, right? It's a temporary one-off instance of the application. And then we would probably push and promote our images up to Artifactory, GCR, ACR, whatever, and then we'll deploy into Kubernetes production. So that's what a sort of Kubernetes pipeline should look like, right? One that embraces the idea of shift left and sort of has native support for all those technologies. So to demonstrate that, I've got a voting app here. It's this demo application that you're welcome to grab. You can see the GitHub URL here. And this one is a great demo for Helm because it is 5 different services. It's 5 different sort of components. There's a Python app, there's a Node.js app, there's a Postgres instance, there's a Redis instance, there's a .NET worker, and we've packaged all of this together as a Helm chart. And Helm is going to make the shift left process with Kubernetes a lot easier because I can basically say, well, stand up this whole stack in a one-off, in a short-lived environment so I can validate it. And then once I've done that, I can deploy, with confidence, knowing that I've fully validated my application. So feel free to snag this and replicate this demo yourself. It's actually what to do is make a commit, and we're going to push it. We're going to build our images and chart. We're going to deploy to a one-off environment, a short-lived environment, so we can run that Saucelabs functional testing. Then we'll deploy to production. We could have some sort of step to validate that, and then we'll capture metadata. Now, when we do this deploy step, you could do like a canary release. That's actually what we kind of call shift right. So you want to shift left and shift right. That's a topic for another day. So love to explore that more, but and we have other videos on canary releases, but we're going to focus on this shift left functional testing step here. So let's jump in and look at the demo here, and we'll switch screens here. So here I am inside of Codefresh, and you can see I have a whole bunch of repositories here. Each of these have a bunch of different pipelines associated with them. Just to show you the app we're going to be working with, I'm going to go over to my Kubernetes dashboard and look at my Helm releases, and we can see there's this prod voting app. This is what we're actually working with. And if we open up the vote screen, and the results screen, we'll see that this is actually a survey for who do you like more, Vader or Kylo. That would be Kylo Ren. Now I'm old school. I like Vader more. I think he's a better villain. He's got the deeper voice. His lightsaber doesn't have a bunch of extra nonsense on it, so I'm going to go with Vader on this. And if we look on the results, we'll see that Vader is in fact winning because there's only been one vote. It's just me. So that's our quote-unquote production application. And normally, you actually wouldn't see this staging instance here because it gets deleted automatically. But I've shut that off so that you'll be able to see, you'll be able to look at it after it's deployed. Now, if we look at the history here, we can actually see all of the releases that have been complete with any changes to the chart, and we can actually issue rollbacks to previous revisions if we want to. And we can also see the Helm chart and all the values that we passed when we deployed it, as well as the rendered Kubernetes manifests that we actually applied. So that's the introduction to our application. Let's make a change. So I have this as Vader versus Kylo, but there are other great matchups that we could do. For instance, let's go ahead and do let's change this. Now this won't change the results page, but instead of Vader versus Kylo, let's say Vader versus Yoda, because we never really actually got to see them fight. And I think that would have been pretty cool. So let's go ahead and commit that. Let's do Vader versus Yoda. And we're going to go and look at the pipeline as this runs, and you'll be able to see what's actually happening. Push as this builds. Now, in this case, as I mentioned, this actually has three different, yeah, you can see the builds kicked off here. This actually has three images that we need to build. If you remember in our test app, we had, let's see, we had Python, Node, and .NET, which were all images we need to build, and then we had Redis and Postgres, which were off-the-shelf images. So what this will actually do here is it will kick off, it has this pipeline, it will kick off three other pipelines, there they go, just to build those images. You can see this is the result image, this is the vote image, and this is the worker image. This is the .NET one. And those three things are actually going to build concurrently. And when they're done, it will fire off the rest of the pipeline. It will actually deploy into our one-off environment, and we'll be able to look at and validate that. So that's actually what Saucelabs, we're going to throw Saucelabs against to do that. Now, when we build these images, we've actually spent, I would say, thousands of hours optimizing how we build Docker images. So you can see these are building incredibly fast because we have spent so much time optimizing how we build those images. We cache all the layers, we actually cache the build volume. Another thing that we do, and you can see now the staging has deployed, took about 8 seconds. It grabbed the endpoint, and now it's going to run some test images here. And another thing that we do is each of these steps that you see in the pipeline, it actually runs inside of its own container. And because it does that, we're able to have incredible flexibility. You can actually just send different images to run for a different step. So you can have different versions of different libraries inside of the same pipeline, for example, like different versions of Node or whatever. Here you can see that the tests have actually kicked off, and they're actually going to be running in parallel. So we're going to be able to look at these in Saucelabs in just a sec. I have, I think, 25 concurrent tests available in my account. We'll go look at that in just a second. And that's finished those functional tests. It's going to run some annotation information, and it's actually going to deploy into production. So this pipeline successfully run here, and now it looks like it's in production. So we should see that it's Vader versus Yoda. There it is. And under this matchup, I'd actually change my vote to Yoda, 100%. So that's the completed pipeline. Now there was a lot of stuff that happened, and you're kind of thinking like, well, hang on, man, like, what was all that stuff? How did we even, that one-off environment was so quick that I didn't really see it. So we'll actually go in and look at that. And if we open up this staging app, because I set it to not delete, you can actually see everything that's currently running as well as the images that are running. If I open that up, you'll see that there's actually some extra information on this image. So this would be like, let's say that you're coming in as a someone on the DevOps team. You're trying to understand where this image came from, who worked on it. We were actually just looking inside of our Kubernetes dashboard and our releases, and here I can see who made the commit that worked on it. Now in this case, it's me. I'm today was awesome, and I made that commit, and I can actually jump straight into GitHub from the commit shot and actually see what change was made. So this is actually really useful when it comes just to debugging. We can pull this image down. We can see the logs associated with it, the Docker file, and all of the image layers, which is useful for streamlining and optimizing our images. Now, one of the things I want to show you is if I look at my images here and I look at, for example, my tests, we'll see that there's actually a Saucelabs link that will take us into a report of what happened during the build. And here it is. There were actually 4 different tests that we ran. Each of these were Windows, Chrome, and we can actually jump straight into those tests and see exactly what happened. So here's my Vader versus Yoda, and we can see that here all it needed to do was basically load this URL, and it functioned correctly. Now this environment, you'll see this 3.5.202. That will not match this URL because why? And I can't hear you at home if you're talking to the screen, but why is because this URL is our one-off instance, our short-lived environment, and we can actually verify that by going back and looking at our Helm releases and looking at the quote-unquote staging version that we left intact, and we can see that it actually matches this 3.5.202 IP address. So we actually see everything that happened. Now, if we go over to our analytics and we look at our test
Dan,
history.
Quick question for you on that, on the annotations. Does that get updated automatically on the Saucelabs link?
Yes. Yeah. So in this pipeline, we actually this annotation gets set automatically. So every time I make a change, this will be updated with a new link to the report.
Ah, perfect. Thanks.
Yeah. So let's see if I so it'll take you to this screen. Oh, not this screen. It'll take you to. I mean, I just clicked on it. We came to it. It was this screen. It was this screen that showed all of the tests associated. I really should name my tests. I didn't name my tests, but it would look a little bit sharper if I did. Now, if I go over to my analytics and look at my test history, and you can see that today I actually worked on this quite a bit. So if we say the last, let's go last 6 hours, and you'll see that I actually ran a whole bunch of tests, and we can actually see how long they took. So you can see there was one up here that just took a little extra time. This one was probably an instance where I had deleted my quote-unquote staging instance, and so it just took a little bit longer for it to load as it spun up or something. But this is actually really useful because it'll help you see, actually give you sort of a baseline for some performance in a sense, because you actually can see how things are clustered around. Ken, anything else that you would point out from our test history screen?
Yeah, I'd say, there's a color code there. So if you actually went into your tests and kind of annotated them, you could then see pass, fail, error. Right now they're all gray because they're incomplete, they're complete. But one of the cool things with this is if you run the same test continuously over time, this is a great way to determine whether, say, if a test is flaky or not, because you'll get an outlier like you saw there at the top. And if you consistently see outliers like that, that may indicate it's a flaky test, and it may be a network call or some resource you're calling on that's only available intermittently, and that might be what's causing your test to fail. So this is a great way to kind of look at your tests, a single test over time, and see how consistent it is, and whether make a judgment as to how flaky it might be.
Yeah. Okay. Cool. Well, and then the other thing I'd point out is that we got here. Remember, from looking at what image is running, and actually just clicking directly on the image to get linked into Saucelabs and those other things. Now, one other thing that I would point out is in this demo, we basically limited ourselves to showing what we can do with the test UI. I wanted to show you just briefly another example where this one actually has a security report from Twistlock. It has a performance report from BlazeMeter. It's got a Jira ticket associated with it. And this one actually didn't pass quality steps from the UI. So it's got a little bit different history associated with it. For today, we really just wanted to streamline the pipeline and make it as easy and simple as possible. But this gives you just a little bit, to tickle your imagination of the different things you can put into that validation. There's actually quite a few options. So when it comes to kind of this functional testing step, you can actually do all of those integration tests, performance tests, security tests, all those things that you'd like to do. And all those things are sort of integrations inside of Codefresh that we can add in. One of the things I particularly like about the Saucelabs portion is that we can run so many of those UI tests in parallel. Now, I only have 4 tests for this demo, but typically every time you add new elements to your UI, you're going to be adding a test for it. And so to be able to run 25, 100, or 500 concurrent test sessions, pretty valuable, especially when it comes to just keeping those build times in check. And you can see that whole pipeline that we did, it only took about 2 minutes, 16 seconds, very fast. And this means that my engineer who's working on this is going to get that feedback right away. Now, if this build had failed, I actually would have got a Slack notification about it. And it would have said, hey, your build just failed. Whatever you did, it was wrong. You shouldn't have done it. go jump in here and see what's up. And it would take me directly into that build from this view, and I'd be able to figure out anything that had gone wrong. So that's our basic demo here. Now, just to show you kind of an example of what the pipeline looks like, I'm going to jump into my repo here, and you can see all the pipelines I have associated with it. And here you can see there are a number of environmental variables. My Saucelabs access key is actually encrypted. I set that at my pipeline level, but I could set a shared configuration, with encrypted passwords and things, and I can actually add those into my pipeline. So that would be useful from a security standpoint. This pipeline is set to trigger every time I make a change to my repo. I could just as easily trigger it to run every time my registry changes. So if I built a new image and pushed it, that could trigger the pipeline. Or I could set it to run on a cron, basically run once a day. Or again, on the Git, instead of just doing it on the commit, I could have done it based on when pull requests were opened or edited, or any of those things. Or I could actually even trigger it based on a separate pipeline. If I had maybe a pipeline with just configuration, a different repo, maybe one with just a different, maybe my configuration, my YAML configuration sits inside of a config repo. I could actually have it trigger based on that. Now this one was set to run on any branch. We could set conditionals on that, as well as actually modified files. So this example is a mono repo. I've set it so that it builds all 3 images every time I do a commit. I do this because it lets me keep my commit SHA from Git in sync with my commit SHA that I put on my image tag. Some of you may have noticed that when I was looking at my image tag here, it actually has my branch name and my commit SHA on it. So I like to keep those in sync, but maybe you don't want to do that. And so being able to set this pipeline to only run based on basically only build the image when certain directories have changed, that would be an option. And then normally I would keep this YAML inside of my repository, and if you look in here, you'll find that in my repo, you'll see there actually is, there are some demo pipelines here that you can look at with different things. And that actually includes the Saucelabs elements here. Basically, there's a test Docker image that we build that just runs our Python, test suite, which is configured to use Saucelabs and takes these elements as environmental variables. So with that, and then here I've actually got it inline, so I've added a few extra little things that I could do. Basically, I've set my when those tests run successfully, I have an on success step that sets the metadata on those images. And we can do that on fail or just on generic completion. We could set any number of different things there. And then when it comes to release steps, we basically have a built-in process for running with Helm, where you just pass in the environmental variables for your release, and you can overwrite, chart values or things like that, which makes it pretty useful. And again, we are basically running this. Where's our? Here we go. This is our staging, quote unquote, step. And I say it in quotes because this is a short-lived environment, and I can have duplicates of this. I can have any number of these happening at the same time. There's nothing to stop me from doing that. So that's how that is working. Now, from a scalability standpoint, that basically means that I can have any number of people running this pipeline simultaneously, and I won't have a conflict on the staging side because they're basically running their own staging. And that means that coming back up to this shift left, I can run that every time I do a commit. And that's when it's the cheapest to make those fixes. So with that, I think I've shown the whole demo. We've seen the whole thing. So that is, again, thank you for joining us so we can take some questions.
Yeah, thanks, Dan. That was great. I really like seeing the whole kind of CI/CD pipeline kind of illustrated in one fell swoop. That's kind of awesome to see how that works so well together. I know we have
really fun.
Yeah, I know we have there's a free trial on Saucelabs. How do people get access to Codefresh to give this a try?
Yeah, if you just go to codefresh.io, we do have a free tier. You get 120 builds a month for free. And you can actually run this whole demo yourself. You can actually spin up this example voting app if you like. You can throw that Saucelabs integration at it and try it just for yourself.
Okay, thanks everyone for tuning into the presentation. We'll go ahead and get to the questions now. So Dan, do you have those the Q&A questions? Looks like we have 3 in our Q&A section, and if you have any more, please feel free to add them now.
Yeah, good questions. Feel free to add more. I see there's a question here that says, that instance of the application is tested. Is it isolated by namespace, or how is that handled? Good question. In this case, I actually allowed it to be installed in the same namespace. However, there's nothing about this that says that you need to do that. I would recommend actually using a separate cluster when you're doing this kind of thing, because you want to be able to allow people to basically spin up a whole bunch of copies at once of even the same application. So using a sort of a dev cluster is probably a good idea for isolation and for sort of resource isolation. I'll share my screen again really quick here and just show, get out of here. This is the step where it installs the short-lived environment, the so-called staging one, staging in quotes. And you can see here, there's an option to set the Kubernetes context and the namespace. I could set the namespace to be whatever. I could set the context to be whatever. And I have a blog post about how to create namespaces dynamically. So you could actually create a new namespace for each branch or each commit or each pipeline run, and then delete the namespace when you're done. So good question. This is a good question from Esteban. It says, I like the idea of shifting left, but temporary canary solutions don't work when you have a subset of users that need to do elongated testing efforts for various days, testing complex algorithmic changes, complex mechanical changes, which require further and ongoing testing by stakeholders. How does this model fit into those types of needs? Well, I think actually, and this is sort of funny, but I think that you need both a shift left approach, which is what we did in this webinar today. And I think you also need a shift right approach where you do canary, but you can even do longer canary. And there's actually, I want to put together a webinar on this soon. With Istio, you also have the option of creating mirrors. So in the canary webinar that we did, and we compressed that canary release down to a few minutes, but you could elongate it to several days or weeks. In that instance, what we did is we popped in the canary version of our application alongside of our production application and then siphoned off some traffic. Istio has another ability called mirroring, where what you can do is you can basically have all of your traffic go to production, but have the traffic sort of duplicate and go into your mirror instance, and none of that information comes back to the end user. And then you can basically do a burn-in on that new version with live data, kind of live interactions, but none of it actually affects users. So that's something that I'll hopefully do a video on here soon. So I think you need both a shift left and a shift right approach, to be honest. The shift left stuff is going to catch what I would call most of the dumb stuff, like, oh, once it went into Kubernetes, on my local environment, like I had Minikube set up in this way and then it didn't work. You'll catch that stuff by shifting left, and you'll catch like security, you'll catch UI tests, a lot of those things you'll catch by shifting left. The more complex stuff of like algorithmic changes, depending on what you're doing, shift right is probably going to be the best answer there. And I also just would mention that we have I would love to do another video on this. We have a customer, one of the big TV companies, I can't say who they are, but they use us to do all their machine learning testing. They use Codefresh to do all their machine learning testing because they can spin up the environments and run everything that they need, even for a week or whatever, and then pull it down. Because you do have the option to run cron jobs and other kinds of triggers, and you can actually trigger things from, anyway, I'm spinning off into a bunch of complex stuff. So I'm sorry, that's probably just more confusing than anything. Barack asks, how do you merge changes to master back to development branch? Is that managed on the SCM side? Yes, that's managed on the SCM side. Here we are basically following the lead from Git. And in this particular demo, we basically just dealt with the master branch. When you're in a Codefresh pipeline and you're looking at triggers though, you can set up triggers based on pull requests that would do this work. And then you can actually have it, you could have a step that actually even approve the pull request if you wanted. But if you look at the Git events, you can see that you can actually trigger pipelines based on pull requests opening, pull requests being closed, being assigned, basically all these things. The options for triggers on Git vary by your provider. So GitHub has the most, Bitbucket has fewer, GitLab has fewer. Good question. There was a question at the very beginning from Jose who asked, that instance of the application is tested, is it? Oh, no, we answered that one. Oh, Barack, you asked, why are we rebuilding the other two images if only one commit was made to the repo? Have the other images source code changed, probably is what you're asking. Good question. So there's basically, when it comes to, there's kind of a tension in Kubernetes, I would say, which is that you have, well, let me back up. Depending on how you want to operate. So there's this idea called Git ops, which is that Git should be the source of truth for how my application is currently running. And if I do a Git revert, it should trigger things to sync into Kubernetes, and including changing the images and those kinds of things, which we support. And in this particular demo, what we do is we actually run those builds. So we actually build 3 images. So you'll see this is the example that we did. It took 2.5 minutes, and then it built 3 images because our application has 3 images that need to be built. Now we only changed one of them, but I wanted my image commit, my image tag to match my commit. so that I would have parity between my repo and my images. Now, if you don't want to do that, which is just fine, on your Git trigger, what you'll do is you'll set an expression selecting which folders. So you can see there's this modified files. This is a mono repo feature where you can basically say, well, I only want to rebuild, an image. I only want to run this pipeline if this folder changes. And then we would only build the images that needed to be built for any given change. So it's just kind of a question of what your priority is. In this case, I wanted to keep parity between my image tags as well as my my repo. Another way to do it would be to basically update the tags on my images. I'm not sure if I like that approach, but yeah, there's some options. Okay, here's a question from Romaine. How do you deal with test data in the app? Is everything needed to be mocked in dev for unit and functional tests? It is a good deal to prepare a small production dump of databases to be run in testing stages. Yeah, there are two approaches to this that are very common. One is to package up like a nightly, or just package up like a container that has data in it, and not like, so like package up your SQL database, for example, in a container that you just use for testing, and then it's just always the same test data set. I think that's just fine. But depending on what you're doing, we also did a webinar with Portworx, and I recommend you would watch this video. It's codefresh.io/events, and it's this continuous delivery for stateful applications with Kubernetes. And there, what we did is we actually snapshot data that's in production and load it into our test instance, and we do it inside of a pipeline, and it takes less than, I mean, that whole pipeline takes like 2 or 3 minutes to run, even with all the testing it's doing. So it actually uses live data in the test instance, and it loads in that live data every time it runs. So that's the more thorough approach. And if you watch this, there's some interesting conversation we have around PII and the implications there, but this is a pretty popular approach for that. So I recommend you watch that video to get the full in-depth answer. So with that, I think there were also just some discussion in the chat. Let's see. I thought the 3 images were 3 different repos. Yeah, we talked about that. Does Codefresh have any support for Bitnami's sealed secrets app? Basically, it allows you to encrypt your secrets, store them in Git, and decrypt them in deployment. Does Codefresh support this, or do you support adding a custom step to decrypt secrets? We don't have a built-in step to handle it, but you can easily create a custom step to decrypt those secrets and then add them into your pipeline to be used. So this is very possible. We had somebody run an example using let's see, encrypt. What's that called? BitLocker. Very, very similar to Bitnami's app, and they just made a custom step to do it. It was pretty straightforward. So feel free to reach out if you want to do this. I'd be happy to partner with you on it, and we can get a blog post up. So Scott, that's for you to come back and we can talk about it. Let's see. And then there was this other question. What Git branching strategies do you recommend to work best with Codefresh, Git Flow, or GitHub Flow? I'm not sure that I am well versed enough on the differences between those branching strategies to have an opinion on it. I would say that truthfully, whichever branching strategy you want to do will work with Codefresh because you have so much granular control over the triggers. So I don't expect that you'd run into any issues with either flow. But let me know if you have a different experience. How do you merge changes to master back to the development branch? Oh yeah, we asked that. How do you manage to optimize the Docker images? So this is a great question. In code, so there are a couple of things on the optimization front that I can answer. One, we've spent probably thousands of hours optimizing how we build Docker images. So when that pipeline runs, it actually loads in a build volume that was used on the last build. and we cache all of the layers, we reattach that, and then we have the built-in Docker registry. So if we do need to pull anything, it pulls very, very quickly. So there are a couple of things that we do there. When it comes to optimizing the size of the Docker images, we the only help that we really offer there is a report showing you the layers in your image. So if I come back and share my screen again, let's go look at one of the images that we built today. And if we look at the layers, this will actually show you a view of each layer that's added into the container and the size of it. And so you can see what's taking the most size. Now, to get this step down, what you really need to do is, and this is true, take this as a maxim about Docker. To optimize a Docker image, you must use multi-stage Docker builds, period. And when you do that, it makes a world of difference. I recently did a Go app where I did a non-multi-stage build first, and my Go app was, my image was about 200 megs, and then I did a multi-stage build and it was about 10 megs. Because by doing a multi-stage, you can move only the thing that you actually need to run your application. So hopefully that's helpful. Let's see there. Gosh, there was a lot of discussion during this, and so I missed some of it. Quick question, maybe we'll cover this. How does the Codefresh connect to Kubernetes cluster? Do you need to expose the API publicly, or do you run a container on the cluster itself? Never mind, I found it on the dashboard. For those that did not find it, I'll share my screen again. If you go to Kubernetes here and you hit add cluster, you can see that I'm on GCP. I'll revoke this so we can watch this fun happen. Let's see, hit revoke. There we go. So I'm going to authenticate here, and it'll give me my my Google sign in here, and I'll sign in, and I'll hit allow. And now that I've done that, I can actually browse my projects that I have in Google Cloud and load those in from here. So I could take, let's see, do I have anything in this class, in this project? Oh yeah, so I could take one of these and add it into my project. So that's how you add clusters. The other way you add clusters, if you're not using GCP, we have a bunch of providers here, but let's just say you've got your own custom cluster. You basically need to set a certificate and a token and their instructions on how to get that. This does obey RBAC rules. Now, if the cluster is behind a firewall and you need to keep things inside the firewall, we do have a hybrid model where you can basically deploy a container on your cluster, which will sort of act as an agent that can do the work behind the firewall. So good question on that. Let's see, any other questions here? A couple new messages. Thanks everyone, very interested. Cool, Scott's gonna reach out. All right, so with that, I think we answered all the questions, and feel free to hit me up on Twitter. I'm at @todayWasAwesome, or feel free to reach out to Codefresh @Codefresh. And I would just say, create a free Codefresh account and start playing around with this stuff, and you'll see that we have a lot of examples, and you can basically replicate what we did here today in just a few minutes. It's very satisfying to be able to, to get stuff actually deploying onto your cluster. And a lot of people ask me, how do you learn Kubernetes? How do you get your engineers to learn Kubernetes? And the truth is that when I started at Codefresh, I didn't know a whole lot about Kubernetes or really containers, but a lot of my learning actually came because stuff in the Codefresh UI was exposed in a way where I could work with it very easily. And then I could work my way into like, oh, okay, what's going on behind the scenes. I created a secret in the dashboard. How do I do that, in the terminal, and how does kube control, ferry over? And so just one aside before we end, Giphy, the Giphy.com. I don't know if you've seen it. They provide GIFs on Twitter, and they serve, I think, 5 billion GIFs a day. They're Codefresh customers, Codefresh users. And what they did to get everybody onto Kubernetes is they called a meeting. They brought all their engineers into a room. They said, here's the Codefresh account. Let's all set up our pipelines. And within about 40 minutes, they'd migrated the entire company over to Kubernetes because they were able to get their pipelines up and running. So that's the kind of experience, that's the kind of story I love to tell, and hope that will be repeated often. So with that, thank you very much. We really, really appreciate you coming. Tell other people about all the events we're doing. Go check out codefresh.io/events. Watch our replays. Watch our Canary videos. You can subscribe to us on YouTube, and you'll see some of the videos there. You can follow us on Facebook, and you'll get some of these videos there as well. And then last thing I would just say, go create a free Codefresh account, invite a couple collaborators, and start jamming on a project. And I love to hear about everything that people work on. So as you work on stuff, hit me up on Twitter, send me a message on Intercom. There's a little chat button when you're inside of Codefresh. I'm thrilled to talk about it and just get excited with you. So let us know if you guys need any help. And as always, have a great day. Thanks.